So the test for the periods 9 and 10 is here. And the first question they want to know is if P is false, and Q is true, what about P or Q? Well, P or Q is true if either of them are true, and since the second one is, that one's true. P implies Q. So that one is only false only if its T implies F, which is not what this situation was, so the second answer is true. The third one, not P and Q, well, since P was given as false, not P is true, Q is true, and is true if they're both true, which it is. And in this one, has a lot going on. P and not Q, which is false, and false, which is definitely false. And the other one, not P or Q, not P is true, P is false, so not P is true, regardless of what Q was. If one of them's true, if at least one's true, and then finally false and true, they have to both be true, so that one is false. Question 4, if it's good for the goose, then it's good for the gander, so that's P implies Q. And this one is, if it's good for the gander, then it's good for the goose, that's Q implies P. And that one is the converse. The inverse is when you have P implies Q and it turns into not P implies not Q. So if the shape is a triangle, then it's a polygon. So change it to, if the shape is not a triangle, then it is not a polygon. The answer choices might be different because I changed them around a little because there were too many A's, but that's the answer choice for this one. If it's not a triangle, then it's not. If it's not a triangle, then it's not a polygon. Number 7. So this one's kind of funny because you see there are 3 trues and a false, which actually happens for or statements. And it also happens for if-then statements. So this potentially could have been an or statement, like that. It's just that it isn't, because P or not Q would be false when both of those things are false. But if P is true and P is true, so P or not Q is going to be true. So it's not this. So our only possibility is choice A, but the reason why is choice A is that a conditional is false when this is true and that's false, which is what's happening in this situation, because P is true, but Q is false, so not Q is false. And that is the situation we look for. Again, the answer choices changed since I made this key because I had so many A's, but that's the idea. So for this one, it looks like it could be detachment, or it could be modus tollens. Detachment would be P implies Q, and then they would tell us the P matching up. The answer would be not Q, which is not what happened here. And De Morgan's would be P implies not Q, and the opposite of the thing on the right. But that's neither of these cases. It looks like it could be something, but it's actually not valid. In this one, not P or Q. So since P is given as true, not Q is false, which means Q has to be true, and that's what disjunctive inference is. And number 11, this is a modus tollens situation because I have P implies not Q, and then the opposite of the thing on the right is there, which makes the opposite of the thing on the left there, Morse. And this one over here, this is exactly what De Morgan's is. It's almost like distributing the not sign through, but we flip the or sign over. And over here, as weird as this thing is, false implies false. Anything except for true implies false is true, so this is true also. Okay, let's look at the second page. Logically equivalent, they're basically asking for the contrapositive, which is logically equivalent to the original. So if I say, if you watch a pot, so I'm telling you P implies not boil is not Q. So we want to turn it into the contrapositive where we reverse the direction and we negate both things. So that would say, if it boils, then you did not watch it. Now this truth table here, let's look at what happens. Not P is the opposite of P, so if this is TTFF, this is FFTT. Same thing with not Q, it's the opposite of this. TFTF is FTFT. Now for this one, we want to not P or Q, so we have the not P column and the Q column, and we want, if both are false, then it's false. Any other situation is true. So this is true, false, true, true. Now, P and not Q is using this, and it's and. So either they're both true, which they are here. Any other situation is false. So it's false, true, false, false. And then finally, this is a combination of these two columns. And unless it's true on the left and false on the right, it's true. So I'm looking for true on the left, false on the right, true on the left, false on the right, true on the left, false on the right, false, true, that's okay. So the answer is false, true, false, false. Now for this one, to create the truth table, I need a column for this, which I have here. I need a column for this, which I have here. And since this one here has a not Q, I also made a not Q column. Not Q is the opposite of Q, so Q is true, false, true, false. So this is false, true, false, true. P or not Q, I'm taking these two columns, and I'm looking for a place where they're both P or not Q. I'm looking for a place, hold on a sec. Okay, yes. So P or not Q is only false when they're both false. Otherwise it's true. Now for Q implies P, I'm going to sort of take this column and this one, but I'm looking for Q to be true while P is false, which is this one. But that's why the rest of them are true. And then finally, the biconditional says, are they the same or not? True, true, they're the same. True, true, they're the same. False, false, they're the same. True, true, they're the same. And that's why these are all true, so it is a tautology. Okay, now the logic proofs. So we start with the B. And as you can see, whoops, that's too thick. So we start with the B. And as you notice, this A implies not B. These two fit together as a contrapositive, as a modus tollens situation, because this B is the opposite of the thing on the right. So the conclusion you can make is the thing on the left. And that's why the next step is not A, modus tollens. Now that I have the not A, I can combine it with this or statement. A is false, so this A is false, which means not C has to be true. And that's what disjunctive inference is. And then finally, maybe get another color here. Now that we have the not C, that can be put together with this statement. The not C matches with the thing on the left, so the conclusion that you could make is the thing on the right, which is D, and that's modus ponens, or detachment. Now this last question doesn't have, see on this one we had a single letter. This one doesn't have anything like that, but it has this thing which I can expand with De Morgan's rules. It becomes not E and F. Now either of these things can be split out to become a single letter that we're going to need to get sort of the ball rolling. Now, there's no E's in the entire proof except for this one, so this F is going to be the one that I am going to pull out by simplification. Now that I have the F, which is also part of this, those fit together. We have the thing on the right is not F, and here I have the opposite of that being true. Modus tollens says that now the opposite of G is true, so I can say not G by modus tollens. Now that I have that not G, it fits nicely with this thing, because this says either G is true, which it's not, or not H is true, and that's why we have not H. And then finally, that not H goes together with this one. The thing on the left is not H, here's a not H, so we can conclude, we can conclude I, which was the goal, and the reason was detachment. So just to summarize, detachment is when I have like P, Q, P, that's detachment. Modus tollens is P, Q, not Q. And, you could have other situations, like if there was a not Q here, they would be that way, or if there was a not Q there, it would be like that. Okay, well that is test form B.